Hello, Math 20-1. We're here with a group of experts to challenge this topic of max and min challenges. We're here with Bobby, I can do this, and Daniil, I'm going to get it done and own these problems to conquer this. So max and min word problems are a little bit different than the quadratic equation word problems. So just a little introduction. So you had quad equation challenges, and in those, don't forget what you had. You had some kind of a quadratic equation, ax squared plus bx plus c equals 0. And you found the answer to that. That was cool. This is a little bit different in quadratic function problems. They call these optimization questions. And in a quad equation problem, you were finding the x-intercepts. So the reason that I'm explaining this is because what's funny, and it's not really funny when you're the student, but what's funny is that sometimes we try to solve quadratic function problems and we don't know what we're looking for. So you're going to come up with a quad function that represents this problem, okay? And you're going to have y equals ax squared plus bx plus c, okay? That's what you're going to have. Typically, when you have a quad function problem, you're looking for, don't forget, right? We talked about mom and we plotter, but you're going to have, let's just pretend this is the answer to a problem. And somebody says, well, this is my height in meters versus time in second. The question is going to be, in a quad function problem, not when you hit the ground, but the question will be, what's the optimal point of this height versus time graph? And typically, it's the vertex. And so if this vertex happens to be at 3 seconds and 102 meters above the ground, that's the point we're interested in. We're interested in the vertex, and that's what a quadratic function is. Whereas quadratic equation, you might have the same equation, but you're interested in the x-intercepts. And these things can kind of go together, right? So just making sure we're clear what we're trying to find. Okay, so we'll start off with, I guess, a basic problem. And so we'll read the question first, and it says find two numbers. So the very first thing I want you to do, and it doesn't show it in your notes, is I want you to say what it is you're trying to minimize. So you'll notice in my blue, I wrote down, for 1 mark, I just need you to simply say, what is it you're trying to optimize? Let P equal the product that we want to minimize. You want to find that product. So you're looking for two numbers that have a difference of 24. So I'm just going to ask the panel with us today, give me two numbers that have a difference of 24. Any two numbers. So Bobby and Daniil can kind of brainstorm, and they can just say, here's my first number and here's my second number. So if your first number is, let's say, Bobby, 6. Then Daniil's got to come up with a number that has a difference of 24. So he's got to pick something like 30. Now, 30 times 6, we look at the product. 30 times 6 is 180. Now, the question is, can we come up with a pair of numbers that have a product that's a minimum? So that's 180. So then we try something else, like Conrad might say 5. We're just going to kind of go in order. Conrad might say 5, so then Daniil has to say, has to be a different. Oh, wait, did we do that right? 19. Because they had a difference. You're right. This one had a difference of 24. So now we're going to have. Now, if he went down one, you're going to have. We got to go 29 then, right? Because 29 minus 5 is. So they still have that difference of 24. Okay. So now we got. What are we at now? Well, we're smaller. I think 29 times 5. That's 145, right? Okay. So is that a product min? Well, we'll keep playing around. So we could go 4. That means this has to be 28. And I don't know, help me out. 28 times 4, so that's 4 times 20 is 80, 112. Okay, so the point is we could do this question. It's really trivial. Probably wouldn't ask this question on a test because in this case, we could do this by trial and error and we'll find it. And I can tell you right now, it happens when you're balanced. And if we keep going down, you'll find that there's a, if you did this table of values and you worked your way down, you're going to find something special happens at 12 and minus 12, or the other way around. You're going to find out, because I'm psychic, that the answer is minus 144. But this isn't using math. This is using That's just using guess and check, and we're amazing, so we found it. So what do we want to do? We want to come up with an equation. So this is a nice simple equation, sorry, nice simple question to get us started. So that's trial and error. I'm guessing that my answer is going to be 12 and minus 12, and it has the smallest product of negative 144. But let's see how it works with math, right? So let's come up with an equation. P is the product I want to minimize. Well, what are my numbers? Well, my first number is x, and my second number is y. That's what we were looking at with Bobby and Danilo. So this is x, and this is y. That's cool. And so then what's the product of two numbers? Well, obviously, your product would be, whoopsie, my product is going to be x times y, okay? Now, anytime you have an equation, don't look at the little parabola hanging out there. That'll come into play in a second. So my product is P, x is my first, y is my second. My product, my quadratic equation is this right here. But it's kind of useless because you need to create a quadratic equation with only one variable. So you have to rewrite it, and you have to use the other stuff you know. So if we know that x minus y is 24, the difference between the two numbers is 24, we can use substitution and come up with an equation that looks like this. Okay? So if x minus y is 24, pick one of the variables to solve for. It doesn't matter which one. Solve for that variable and use substitution to sub it in there. Okay? And so we end up with P equals x times x minus 24. Okay? I would suggest maybe you multiply that out, and you have an equation of x squared minus 24x. Now, what you know is that that's a quad function. You know that that quad function has some kind of a parabola. It turns out because this is a 1, so what I'm doing is I'm saying, well, it's going to have some picture. It's going to have some picture. It's a happy parabola. It's a happy parabola. What does it look like? How do I know where the vertex of this parabola is? Well, what you just learned yesterday was how to complete the square. You need to find the vertex of that parabola. Where is it? If you used your graphing calculator, you could find it, but let's just review what we did from last day and complete the square. So if you complete the square, right, you're going to get x minus 12 squared minus 144. Notice I didn't do any of the work. I just did it because I'm smart, right? And I went through the work and I showed it, okay? So what do we know about this? If you were to graph this parabola, right, now that you've completed the square, you graph it. Okay, so I just want you to draw a quick sketch so we know what we're talking about. Where's the vertex? The vertex is at 12 and minus 144. So it's a happy parabola with the vertex at 12 and minus 144. Cool. There's mom, right? Oopsie. There's mom. What's the answer to the question? This parabola, right. This parabola has a minimum value. That's why defining our variables was so. This parabola has a minimum value of negative 144 when x is 12. But when you drew this little sketch, and I'm going to ask these gentlemen with me, notice that we did not use y as a variable. That's because we're not talking about y. Our y variable is actually product. So you have a minimum y value, which is product, when your x value, when your first number is 12, right? So your points are xp. And so when you look at, well, what was the question again? What are the two numbers so that I have a minimum product? And if one number is 12, y is the second number. So my second number is, oops, I need to, how can I show that? Oops, there we go. So my second number is negative 12. So therefore, the numbers are 12 and minus 12. Excuse me. Okay, so we didn't solve world hunger. We didn't do anything really crazy, but that's a beginning question for what we need to do in this section. Okay, so we found the vertex by completing the square. Okay, and we'll come on, write down some notes. If there was something that bothered you, please make sure you ask tomorrow. Okay. Okay, next one, you guys. So we're going to go a little quicker because we spent too much time talking. So in problem B, again, find the dimensions of a rectangular lot of maximum area. We need to build a quadratic function. First thing, excuse me, I got a goofy throat. Let A equal the area to maximize. So this is a maximum question. We better get a sad parabola when we do it. We need to find the maximum area and optimize that. So we are looking at a square, sorry, a rectangle. We have lengths and we have widths. We have 1,000 meters of fence to build it, so 2x plus 2y is the perimeter. What's the area for any possible rectangle, right? So you could play, you guys, you could play and you could do trial and error, and if this is 2 and this is 2, then you've used up 900 and what? 996, so you'd have 498 left for the sides, right? And so on and so on. If you made this 10 and this 10, you'd be used up. So that would mean you'd have 490 left on each side to build your fence. And you'd keep playing around until you found the maximum area. But that's not what we want. So let's build an equation. The equation, if A is the area, is area equals length times width, x times y. And you could have picked L and W, whatever you want. So now you say, okay, well, that doesn't do me any good. That's not a quad equation. So again, we use elimination. 2x plus 2y equals 1,000. That means that x plus y equals 500. And now I put that back into my question by solving for one of those variables. Doesn't matter. So if I choose to solve for y, I get y equals minus x plus 500. Boom, you're done. You can type this into your graphing calculator right now. You have the quadratic function. Yes, you complete the square, but because Mr. K is a great guy, you could just go, and I'm going to pause, and I'm going to go and I'm going to graph it on my calculator, and I'm going to find the maximum, okay? From now on, you can simply just graph it. Once you find the quad function, this is a sad quad function, go find the vertex and the maximum, okay? Off you go, come back when you're ready. Okay, so I've closed. We can probably see the answer over on the side, but right now I've got my graphing calculator and I'm supposed to see the max or min. I don't want you to complete the square. I want you to use your calculator. So if I use my calculator, I need to be the brains of the operation. Right now, I can see that this doesn't look much like, oopsie, this doesn't look much like a parabola, right? So I need to fix my graphing calculator. So I need to play with my calculator until I have something in the window that I like. So I'm a pretty smart person. X stands for the width of this. So how wide could it be? Well, if it was a square, it would be 250 on each side. So how about I do this? For anywhere from 0 to, I don't know, I'm going to go from 0 to 300. Okay, I'll go anywhere from 0 to 300. I'm trying to see the maximum of this parabola. And then I go zoom fit, zoom 0. Well, now I did that. I can see, well, I can see the parabola, but I want to see all of it. So second, calculate. Now I'll go, well, maybe I'll go to 500. Oops, I'll set my window, sorry. Set my window from 0 to 500. And now I go zoom fit. Now how do I know that? Because I'm smart. But also because you know that the smallest the width could be would be 0, and the biggest it could be was to use all the fence. So now you can see where's the maximum. Second, calculate maximum is somewhere between, well, we know the middle is 250, but if I go somewhere between whatever, 100 is left and 400 is to the right of that peak, and I ask for a guess, I don't feel like it, the maximum this is 250 and 62,500. So I found the maximum of this quad function by using my graphing calculator. I go back and just like we talked about here, you could have used your completing the square, which is fine, but I did my graphing calculator and I said to myself right here, I saw it on my graphing calculator screen. The graphing calculator showed me that this maximum occurred at 250 for a x value, and the area, whoopsie, and the area was, so my x value was 250 and the area was 62,500, and that's meters squared. So what was the question? The question said, find the dimensions. X refers to the width. So if this is 250, then go back and find out what y is, substitute that in there, and solve for y, and it turned out that the dimensions of the lot were 250 by 250. Okay? Again, ask tomorrow if it doesn't make sense. But you, in order to not complete the square if you don't feel like it, you just need to know what the window in your calculator is to make it work. Okay? Next question. Okay? So we had questions like this in our last unit. So when you got more than or different, I guess, unusual objects. So in this case, you have a corral, and it's enclosed. Now, the reason I put this here is there's a pond, or there's something that you put up. You built your fence up against your shed, so you didn't have to use as much fence. You could use the shed as one of the parts of the enclosure. So the question is, if there's only 3 sides to be enclosed by 1,000 meters of fence, what would that do to the area? Same problem, a little different constraints. Let A equal the area to maximize for 1 mark. Okay? And now you go and do the same. What's area? Still length times width. Right? Area is still length times width. But now when you look at perimeter, perimeter doesn't have 4 sides, so your constraints are, I only need to use 1,000 meters of fence for 3 sides, so y is equal to minus 2x plus 1,000. And you now substitute that into the equation, and your area is now going to be x times y, substitute, and again, there's your quad function. What is your choice? Your choice is now to complete the square, or you could use your graphing calculator, be smart, and find the max or min that you need to find. You decide which way you're going. Exactly. So if you look at this, I've used the same window. I've typed in y equals minus 2x squared plus 1,000, my new equation. Where's the maximum? Where's the optimization of this question? Well, when you look at the graph, you go, yikes, it's off the screen. But if you go zoom, fit. Oh, I did something bad there. Clear. Zoom, fit. Now you can fit in your screen, second, calculate, and you'll find the max. I'm going to go straight to the word problem because you know how to do that. So if you use the maximum, you'll see that whether you complete the square, which is up to you, or whether you use the graphing calculator, you should see that the maximum occurs no longer at 250 and 250 like we saw. This maximum occurs at 250 and the other side is 500. Okay. And so the maximum area now, we can have a much bigger, excuse me, we can have a much bigger pen. Notice we had 62,500. We've doubled the area of our pen by only having 3 sides. So it makes a big difference, obviously, right? Now I want you to try and fly on your own and complete the next one by yourself, okay? And come back and see me. Set up the next one with your let statements and then come back and see me, okay? So you guys have had some time. I wanted you to draw a diagram of what you think these words mean. So let's look and see whether the words have guided you in the right direction. So I've underlined the keywords. As you read a question, make sure you do that. So we've got a rectangular field to be enclosed and 3 smaller plots, 2 fences parallel to one side. Hopefully you came up with a diagram that looks like this. And so you have 4 panels of fence going vertically, or doesn't matter which direction, and then you'd have 2 lengthwise going this way. So you could call them L and W or X and Y, whatever you want. But you must start off by saying that we want to, and I forgot, let A equal the area to, I always want you to say, are you minimizing or maximizing? And this is maximizing. Let A equal the area to maximize. Define your variables. What is X? What is Y? Let A equal the area to maximize. So what's the equation? Oops, I wrote right on top of my equation. Let A equal the area to maximize. Area is X times Y And so now, again, you're stuck with that problem of two variables. We've done it 2 or 3 times. You use the perimeter to substitute another variable in to define another variable. So now your area is x times minus 2x plus 450. Okay? And once again, that's it. That's the hard part of the problem. You go to your graphing calculator, you multiply it out, you complete the square, whatever it is you want to do, and you're done. Okay? That's the problem. The let statements, where the heart of the work is, make your let statements, make your diagram, come up with your equation, and I don't care what way you do it, use your graphing calculator, use completing the square, but find the answer. What does this parabola look like? If you complete the square, you end up with x equals 112.5, but actually if you use your graphing calculator, what you're going to see is x at 112.5, you're going to have a vertex of 112.5, comma, 25,000. Mr. K ran out of room. Okay, so once you have that, whether you got it from your graphing calculator or whether you got it from completing the square, you'll see that your vertex is 112.5 and 25,312.5. And what does that mean in terms of your question? This vertical number is A in meters per squared, and this is X. So what was the question? What is the dimensions and the maximum area of the field? So I know that one of the dimensions is 112.5. That's the X one. Go back and find out what Y is, and Y turns out to be 225. Ask me tomorrow if you had troubles with that, but you just got to sub it back in. And the maximum area of the field is 25,312. Okay? All right, here we are back. Okay, last problem. Money. How much money do you want to make, Daniil? As much as possible. That's what we're all about. As much as possible. That's right. So how do we make the most amount of money possible? How do we generate the maximum revenue? We do some economics. So in this question, we did some economics, and 300 people attend a concert for 20 bucks. But if we were to increase the price by $1 a piece, you say, oh no, you'll lose people. Who cares? We're about money. The fact that not everybody gets to go to the show, that's not our problem. We just want to make the most amount of money, right? Yeah, maybe it's about service, but for now, we're just going to be about money. What price of admission will yield the maximum revenue, and what is this maximum? So the first thing we have to consider is what makes revenue? Well, there's two things that make revenue. What makes revenue is the amount of people that are there and the amount of money that we sell. But the variable in this case isn't about that. The variable is right here. And it says $1 increase in price will make some people not show up. So we're going to lose 10 people for every increase in price. That's what we need to decide. How many increases of $1 should we have? We don't know. We could do trial and error, but we're going to use economics. So let X equal the number of $1 increases in price. The other variable is let R equal the revenue to maximize, okay? So we get 1 mark for defining our variables. The second mark comes in for, do you know what's happening? Well, how much is revenue? Revenue equals cost times number of people. What's the cost? The cost was 20 bucks. How is it being affected, Bobby? How is it being affected? What's happening with X? What's our cost doing? We are doing $1 increments, and we're increasing or decreasing? We are increasing by $1. So the original cost was 20 bucks, and you are increasing that price by $1. So your new cost is going to be 20 plus X. How many people are coming? Well, you used to have 300, but now you're going to lose people. But that's okay, because you might be making more money. So the number of people that are now going to come is 300 minus 10 people for every time you increase. Okay? We go over here. We've got our revenue. My question to you guys everywhere is, what kind of equation is that? What kind of function is that? This is a quad function. You're done. You can go straight to your graphing calculator and you can go find the maximum. So go there, right? Go there and find the maximum. You could complete the square. You could multiply this out and find it. My suggestion is that you don't. Go back to your graphing calculator and find the maximum. because I think this is a lot of work. And if we step out, so I'm going to go back and just pause. So you graph it and you cry because, well, I can't see anything. Well, of course you can't. This doesn't make any sense. Remember what your X and Y variable were. Your X was increase in price. So if you hit window, you need to think about how many increases in price would you have. Remember, you only had a $20 ticket. How many increases in price would you have? Well, let's say you have 10 increases, right? You increase the ticket price by 10 bucks, that's quite a bit. So try, make things reasonable, try 0 to 10, and now go zoom fit, right? So I type the rate, whoa, I can see my maximum. There it is right there. I'm amazing, okay? So there's the maximum. Don't forget what you have here. X is the dollars in increase in price, so it made sense to go somewhere between 0 and 10 because I thought I might find the answer. I now go back to my calculator and go second, calculate my maximum. My left is somewhere from 0 to my right is somewhere 10. I find my maximum is at exactly 5 and 62.50. So the vertex is 5 and 62.50. That's really cool. Don't forget what this is. This is X, and this is revenue in dollars. So the most money that you can make is $6,250. But let's go back to our notes to make sure we're clear. What was the question? The question was, what is the maximum? So what is the maximum? Whether you do it with your graphing calculator like you can see here, or whether you do it with completing the square and all that work, I don't really care. It's wonderful that you can complete the square, but if you can use your graphing calculator, I'm okay with that, right? What should be clear too is how much is the ticket price. The ticket price isn't $5. You had 5 increases of ticket prices, so the ticket price is actually 25 bucks, and therefore that's what the maximum is at 62.50. Okay? All right, so those are the kinds of questions we ask. We'll see you tomorrow. If you have any questions, well done.